In this series on public health engineering, today we shall learn about measurement of dissolved oxygen. As you know that various gases are present in water in dissolved form. One of them is oxygen, which is very important parameter. The amount of oxygen present in dissolved form is known as the DO value. The DO value can be measured primarily by two methods: volumetric method, which is also called as titration method, and potentiometric method. In this program, we will learn about potentiometric method. This is also known as membrane electrode method. In this method, we use an instrument called dissolved oxygen meter. It is popularly known as DO meter. It comes in conjunction with a membrane electrode, a temperature probe. We also need reagents like deionized water, potassium chloride, and sodium sulphite. The DO meter has a set of mode switches. DO switch to be used when measurement for DO are carried out, degree centigrade when temperature measurements are in progress, and standby when the instrument is not in use. 0 and cal knobs are to be used for calibration of the instrument. We have a temperature knob to set the instrument against the known temperature of the solution. The membrane electrode, or which is popularly called as DO probe as well, consists of a silver anode and a gold cathode. There is a thin membrane which is enclosing the electrodes. The membrane is special. It is a good conductor of electricity. It also helps to protect the electrode. When DO probe is dipped into a solution, a diffusion current linearly proportional to the value of molecular oxygen present in it is generated and is converted into concentration units by the meter. To assemble the DO probe, open the cap, now check that the silver anode and the gold cathode are clean and shining. Now we will fill the electrolyte in this tube. First see that the DO membrane is not punctured or torn out. The electrolyte which is used is a KCl solution. Usually a 7.5% solution is recommended as electrolyte. However, we must check up with the recommendations of the manufacturer. Now pour some electrolyte . And slowly insert the electrode. Now some electrolyte will overflow. Now close the cap. check that there are no air bubbles inside. Now, in case this membrane is torn out, it has to be replaced with a new membrane. A new membrane, if it is to be used, has to be activated first, so that it easily diffuses the current. To activate the membrane, put it in cold water for 2 to 3 minutes and then in hot water for 2 to 3 minutes, and repeat the cycle, and the membrane will be ready for use. Or alternatively, you can put the membrane on the electrode, keep it on for 2 hours and repeat the hot water and cold water cycles twice. Now, switch on the instrument and allow it to warm up in standby mode. Now, the instrument has to be calibrated against deionized water, of which DO value is known, and a sodium sulphide solution. The sodium sulphide solution we prepare is of 2% concentration. The sodium sulphide has 0 dissolved oxygen. Now, first we will measure the temperature. The temperature is 24.3, so keep the temperature knob against 24.3. Now, when we do the zero calibration, the cal knob should be on extreme left position. Now, adjust the meter reading with the 0 set knob, so that the display is 0 0. Now, take out the probe and wash it with distilled water. Now, take deionized water the temperature of deionized water is 23.5. The deionized water has standard amount of oxygen dissolved in it. This depends on the temperature. Corresponding to a temperature of 23.5 degrees centigrade, the amount of DO value is 8.38. Now, we will adjust this value using calibration knob. Now, gently stir . Now, the instrument is ready for measurement. Now, take a sample . Dip the DO probe and gently keep stirring. And we will note the reading when it is nearly stable. So, we can say that the DO value for this sample is about 9 mg per liters. Record the value in the proforma. As we said before that presence of dissolved oxygen is essential to make the water wholesome. For all water bodies sustaining aquatic life, a minimum value of about 2 mg per liter of dissolved oxygen should be present. Now, what you have just seen is a laboratory method of measurement. There are more advanced methods which are available. These instruments are microprocessor based. This is one such instrument which is microprocessor based. It is highly compact and very accurate. It comes with a compatible DO electrode or DO probe. You also would require a temperature indicator and deionized water for measurements. Now, let us see what the instrument comprises of. It has a number of buttons on the display panel, a on off switch to switch on or off the instrument, a mode switch to bring the instrument in pressure, temperature or DO mode, cal/oblique measurement switch to bring the instrument either in calibration or in measurement mode. Then we have MI and MR buttons to increase or reduce the displayed values, enter button to enter the data displayed, and hold to freeze the displayed reading till we further press it again, and a set button for carrying out the internal settings of the instrument. The DO probe has a temperature sensor. It also has two electrodes, one of which is visible here and another is inside, and both of them are in contact with an electrolyte. Now, since DO value is dependent on temperature and pressure, therefore, the instrument has to be calibrated for both the parameters. First, we carry out the calibration for pressure. Now, switch on the instrument. So, we can see that a display is made here. On the right side we see mg per liter. This shows that the instrument is in DO mode, and the bottom display shows the temperature, and the ATC annunciator indicates that automatic temperature correction will be carried out by the instrument. When the instrument is ready, the corresponding display will be made on the left side. Now we have to carry out the calibration for pressure mode. So therefore, first we will bring the instrument in pressure mode, press mode. Now when the percent is displayed, that confirms that the instrument is in percent saturation mode. Now press cal switch. Now the instrument is in calibration mode. To carry out the calibration, first we will wash the electrode with the distilled water and wipe it gently and allow it to dry in air. When the reading is stable, simply press enter. Now the calibration for pressure is complete. The second correction is for temperature. To do this, we shall first measure the temperature of the solution. The temperature of the solution is 23.6 degree centigrade. Now the same value has to be adjusted on the instrument. So first we put the instrument in temperature mode. Now press mode. This is in mg per liter. Press cal and mode again. Now the instrument is in temperature mode. Now using MI, we select it 23.6 and press enter. Now the calibration for temperature is complete. The third calibration is carried out for DO values. This is done against a solution of known DO value. We will use deionized water for this purpose. The DO value for deionized water at 23.6 degree centigrade is 8.38. So we will adjust the same value on the instrument. Now put the DO probe in the deionized water. Bring the instrument in calibration mode and adjust the value to 8.38. Now press enter. And now the instrument is calibrated for DO mode as well. Now we can measure the dissolved oxygen of any sample with this instrument. So simply put the electrode into the instrument and check that the instrument is in measurement mode. Gently stir the electrode and when the reading is stable, we shall note down that value. So, the ready annunciator is displayed against a value of 11.01. So, we can say that the dissolved oxygen of this sample is 11.01. Now, with this instrument you can also measure the dissolved oxygen of other water sources, for example a canal or a flowing stream or river or any other source.